What's up, guys? We are back here at Altitude Adjustment in Park City, Utah, and this is episode 3. I'm going to be talking to you all about our entire system that we built for our under slab up here at the project. We've got it almost complete. We're getting ready to pour our basement slab next week, so let's get going.
Altitude Adjustment, a Build Original series, is brought to you by Builders FirstSource, Delta Millworks, Huber Engineered Woods, Pella, and RWC.
So this house has a really unique system that we have designed for the under slab. There's a lot of things happening here, and I want to walk you through what we've done to this point and what we'll be doing before we pour our slab next week. As you can see, we have a walkout basement. As code requires, we have 2 inches of rigid insulation, 4 feet down the foundation wall and 4 feet across the top. This is going to be on all of these walkout walls across the back of the house. From that point, our team came through and installed the radon system. So we have a perforated pipe that runs underneath this entire basement footprint. We identified a location for this radon system to go up through the house. Our goal with this is to create as straight of a shot as we can, somewhere from the basement slab all the way up through the roof. And because this community requires everything be vented out of a chimney, we had to find a chimney location that wasn't packed with other things and that had room to fit another PVC pipe in it. We decided we were going to take this up the master bedroom chimney. Master bedroom sits right above us here. So down here in the lower level, it'll be within a 2x6 wall. We'll take it directly straight up through the chimney that's in the master bedroom, out the chimney cap, and we can put our radon fan up in the attic above the master bedroom. We want to make sure that that's accessible because in the event that that fan goes bad and we need to replace it, it's good to be able to access that and get to it fairly easily. So we actually have an attic access that is about 15 feet away in the master bath. You can climb on over. That'll be exactly where the fan is for this radon system up in the attic. So we'll make it pretty accessible, pretty easy to get to. And we've got a pretty straight shot up and out the house, which is good. This radon system is really important in this area. We can't test this lot for radon ahead of the house being built. And you're just gonna assume that there's going to be radon here. As we are excavating, we're digging through solid rock to get our footings and foundations in. Radon's decomposing rock, the gas that comes from decomposing rock. So just making sure that you're taking care of that ahead of time. This is a fairly inexpensive system. In total, for us to put perforated pipe in, for us to run the PVC up, attach a fan to it, bring power to the fan, that whole entire system's about $2,600 for a house of this size in our market. So it doesn't make sense to not do it, because if you were to put it on after the house was built because the house tested positive for radon, all of this becomes visible on the outside of the house. Not a great look. It's not quite as efficient as it is if you put it under the entire slab at this point. So we got that installed before we did our vapor barrier. So our team came through. We just put a 4-inch perforated pipe across the entire basement that has a sock around it. It is just a very simple system. Gets piped up and out. Our plumber came through and installed all of our sub plumbing. So you'll see a bunch of black vent stacks coming up. This is really important at this stage in this particular project because this basement floor is a polished concrete floor when we're done. There are no floor finishes on it. So making sure that all of these pipes are in the exact correct location at this point is a huge priority. I'm going to take you over here and check out a location where we actually pulled a pipe up in the wrong spot to show you how we're going to change that, shift it over so it's inside of the wall, and what the rest of the system that's underneath my feet is made up of. So this is one of those locations I was just talking about. We have a shower down here in the basement. This is our shower drain. And this is actually the drain for the kitchen island up above. It is really easy to miss if you're not laying things out entirely when you're doing all this sub-rough plumbing. In our case, we have a one-man plumber, so he's by himself. So if he doesn't have a bunch of people out here to help him locate them, it happens. But we'll get that moved over into the wall. It'll run up and catch that kitchen island upstairs, and then we won't have it in the middle of our shower down here in the basement. But that is another big challenge on this project, is because this basement floor is polished, there are no floor finishes. So all of these basement showers are not only polished concrete, but they also have a flush sill. So we have no step coming into the shower, and we have recessed drains, and they're linear drains. All of those design details that the interior designer picks need to be decided before we ever get to this point. Setting these drains in a specific location for the flush drain, the flush shower, so a roll-in shower, no curb, and also knowing that there is no floor finish on this. It's polished concrete, that's it. We have to make sure these get set at the right elevation. We did have to come through earlier today and adjust some of our drains, just because the plumber wasn't aware that some of these things were just polished concrete. Our mechanical room, laundry rooms, the entire lower level, polished concrete. So we had to adjust the height of a lot of these just to accommodate, so that when we get that floor poured, it lines up perfectly with the edge of these drains and just looks really nice and seamless. I want to walk you over here, and then let's look at the rest of what this basement floor has underneath it before we start pouring our slab. We've come through and insulated this entire basement level. The Radiant Heat guys have put down insulation in addition to the stuff that our team has already put down. With it being a Radiant Heat floor, having insulation underneath it is a huge saver. It's going to make this be a lot more energy efficient. It's going to heat and hold heat better. So let's walk over here, check that out. I'm also going to show you the location of where we have our manifolds and where our boilers are going to mount when we get to the end. All right, this is our mechanical room. At this point, this is where we are starting all of our Radiant Heat tubing. This wall will be closed off. We're actually going to mount the boilers to the face of this framed wall. But let's talk a little bit about this Radiant Heat system. So we have the sub-slab insulation that the guys have come through and put down. Then they have this wire mesh that they lay down across the entire basement, which they're tying their tubes to. In previous videos when we posted about Radiant Heat, there's a lot of comments that go back and forth about that wire mesh isn't doing anything for the slab. It's not supposed to. This is not reinforcement for the slab. This is purely a base for the Radiant Heat to get attached to. So you'll see the guys come through with their wire tie guns, and they're just gonna tie this Radiant Heat tubing down to the top of the wire mesh. Keeps everything straight, keeps everything in line. There is a really important method to the way that they're laying this out. The distance between tubes, the length of the pipe itself. You wanna make sure that they're all even so it heats evenly, and laying it out is really based off of that length and where they're taking the tubing. So all of it's gonna come up together here where our boilers will end up when we get to that point. Now, we're using some products from RWC. This is a PEX pipe. It's an oxygen barrier PEX that is typical for what we're going to use on this Radiant Heat system. RWC has also provided us with these HoldRite 90s that we can use as we bend our pipe to come up the wall where our boilers will mount. These are great products. They make it really easy to keep the pipe in line, keep it organized, and also make sure that when we get to the point where we're pulling all of these pipes into the framed wall, we're not dealing with a big bundle of pipe that's all messed up and just kind of tossed in there together. So you'll see the 90s from the HoldRite that are across the bottom, and then all of our tubing's coming out from there. The crew comes through after our radon, after our sub-rough plumbing, and installs all of this rigid insulation. Once they get that down, that's at the point when they're gonna put the wire mesh down and start tying all of our tubing. Now, we've talked about it a bunch. This basement floor is a polished concrete floor. Concrete cracks. It's not if it'll crack, it's when it'll crack, it's going to crack. So our plan here is once we've got all the Radiant Heat tubing done, we actually have an inspector coming on Tuesday to inspect all the piping, make sure we've got it exactly how we need it. And then from that point, we're gonna come in and tie a rebar mat across this basement floor. That'll make it just one extra thing that'll help keep that concrete together. We can't stop the concrete from cracking, but we can try and minimize it as much as possible. So that rebar mat's gonna help as we tie it through over the top of this Radiant Heat. let's walk over here and check out the detail of this basement and talk about how we have things coming up as we move forward in construction. So the combination of this entire system is what creates a really smart sub-slab system. A couple things I want to just note about the Stego. We're using the Stego Home. This is a 10 mil. The green is 10. Usually you'll see a yellow. That's a 15 mil vapor barrier. We're using the 10. Code requires a minimum of 6. This is kind of our standard minimum for our team. Now, because of the way our foundation walls are, we're 4 feet underground. We're taking this Stego right over the top of that foundation wall underneath our slab itself. We need to attach this Stego to the top of the foundation wall, or in this case, the recess of where the slab will get poured. Our team has gone back and forth a few times with the tape, the tack tape, that is like a double-sided, almost like a mastic tape, or using just the liquid itself. We've just found in most cases, the liquid is a whole lot easier for us to apply and attach the Stego to the top of the foundation with. The tack tape can get challenging, even if we come through and clean off the top of the foundation walls, blow them off with a blower. It's still sometimes challenging to get that other side of the double-sided tape off. But that's one of the cool things that I love about Stego is they offer multiple products. So if that tack tape doesn't work for you, you can always use the fluid and just put it on. And in our case, we've just brushed it onto the foundation wall and then overlapped the Stego over the top of that. Another really cool thing that Stego just did is they just revamped their tape, their Stego Home tape. This is a really great product. Our team used the old version of it, definitely like the new version a whole lot better. And it's also really smart to pre-plan your layout of your vapor barrier. We did that, and in this case, we were able to order some really wide rolls of the vapor barrier. We actually have very few seams that we've had to tape because of the shape of the house, the layout of the house. We've been able to get most spaces pretty tight without having to have a tape line through it. In the lower level, we've used our Stego Home tape to tape around all of our plumbing pipes that are coming up through our vapor barrier. You'll notice that they have a foam sill around them, and then we've used the Stego Home tape just to seal that. The cool thing about the vapor barrier, it's also going to help with our radon system. So it's going to help trap that gas under the slab, really force it to go through the radon pipe, which then gets pulled up and out the attic, and we're just getting rid of that radon. So this is just kind of a standard process for us. The vapor barrier isn't crazy expensive. This isn't one of those additions that you're going to add to your house that's really going to make a huge impact on the overall cost. On a house this size, it was a few $1,000s, but overall the benefit that it provides is tenfold. It's also code. You will notice a lot of builders in Utah aren't doing it or aren't using it. The reason mostly is because this is not an item that gets inspected by the building inspectors. There's also a little bit of complaints back and forth with flat work guys that are saying that the Stego or the vapor barrier causes inconsistent curing in the concrete slab, which causes cracking. There could be some truth to the vapor barrier helping that concrete crack, but in all reality, it's just about getting the concrete supplier to mix the right aggregate, knowing that you're pouring it over the top of the vapor barrier, and having a flat work contractor that's familiar with it. We should all be using it at this point. I think we're getting to a point where it's becoming more common, but unfortunately, this is still something that is not really put into every build in the state of Utah yet. And most of the time people are getting away with it because it's not inspected by a building inspector. So no one to come back and double check that they've put it in. But I would always recommend you ask your builder to install a vapor barrier. Meets code, but it also helps with radon, lots of other things. It's also gonna help our concrete in the future. So super easy. This install on this house took us about 1 full day with 3 guys working on it. And this is a pretty big footprint. So goes quick, it's inexpensive to install, and it's absolutely worth your money. The other thing I want to talk to you about, in episode 2, we talked a lot about our backfill and how we were backfilling this house because of some of the limitations we have with the limit of disturbance. but also some of the limitations that we have with these gigantic concrete walls and the reach that we have to get from them. So a little bit about the access. If you didn't watch the other videos, we have a limit of disturbance, which tells us you can't disturb all of this natural scrub oak, natural trees, more than 10 feet away from the house. So we've got spots around the side of the house that are 6 feet in some cases, 10 feet in other cases, but it's hard to get machines around here in order to backfill this. Now, this structure is our swimming pool structure. So our swimming pool sits inside of this on the next level of the home. So in order to reach this, what we ended up doing was we had a conveyor belt come through. We set the conveyor belt up at the top of the lot and we filled that with engineered fill dirt. So filling this thing up, our swimming pool is 4 feet deep. This entire thing has about 15 to 18 feet of backfill in it, depending on where it's at. So what we ended up doing, we filled part of it up with rock. We had some rock that we needed to put in underneath anyways. And then we got the rest of it filled with engineered fill dirt. The only way we could reach that was with that conveyor belt. So that made it really easy. It is another added cost because we're renting the conveyor belt to come out and fill that up with engineered fill. But then we were able to crane in a compactor, have the guys go through and compact this space. We were also able to backfill it halfway, then get some people inside of it to finish the waterproofing on the inside of those walls. Because the swimming pool sits inside of it, the swimming pool structure itself will get formed and poured up against the foundation wall of the retaining wall. So we want to make sure that we have that waterproofing between those two concrete walls just to protect it in the event that anything did happen with the swimming pool. This bunk room that we're in right now would be protected from the water that could possibly end up in that spot. Let's walk around back, see how this backfill and excavation came together. We're just getting ready to start setting all of our big boulder retaining walls. So I want to walk you around the house and kind of show you how our grade is coming together, how we're going to handle some of these significant grade changes and some challenges that are going to come up that we need to figure out how to handle and get moving so that we can get this house closed in before winter. So this is the back side of the house. You've probably seen that amazing drone shot as we fly into the back of the house coming up from the lake. These are those big, huge retaining walls that we saw on that side before we got backfilled. These retaining walls are purely meant to hold up the house itself, but we didn't want to see these big concrete walls from the bottom of the lake and just have it look cold and not finished. So what we're doing here is we've actually backfilled the entire thing with dirt, and they're gonna be able to use these as planters. So we've installed a drain in the bottom of them. So they can come in, they can water the inside of these, they can use them as planters. We're gonna cover the face of these walls with the same stone that the rest of the house has on it. Then when you're looking at the house from down on the lake side, looking back up, this looks just as beautiful as the rest of the house does. Now, these retaining walls are a total of about 28 feet tall for this last one. They have footings on them that are over 8 feet wide. These are massive walls that are holding up a ton of weight. But once you get the back of this house backfilled, get everything kind of graded close to the final grade, it actually doesn't feel as bad as it looked before backfill. We still have quite a bit to do on this back side with our boulder retaining walls. Part of what we have to get to is this final grade. So we have our limit of disturbance, which we have not touched the dirt on this other side. Once we get our final grade done, we have to make sure that our final grade matches the grade outside of the limit of disturbance perfectly. That is when we finally got to the point where they'll allow us to landscape. So in order to do that in a few areas, like this side up over here, we're gonna have to start building some retaining walls to hold a lot of this dirt. Let's walk over to this side and check that out. I'll let you know what our plan is to get these retaining walls installed and also how we're gonna integrate our retention ponds within these areas. So this whole area over here still needs to get brought up quite a bit so that we can meet with our natural grade on the other side of the LOD. What our plan is here is we've ordered some really cool boulders from Idaho that we're having trucked in this weekend. We're gonna get this boulder wall installed that'll wrap around from this retaining wall over to the side of the house. That'll allow us to fill in this top portion with engineered fill, a little bit of gravel, but that becomes our lower level patio. So we have a few doors that walk out onto this lower patio and a spiral staircase that'll take us up top to the pool deck. But in order to create this flat spot, we're gonna install our boulder walls. So we'll get this put in, we'll get the top filled in, and then from that point, we can now come over here and all this dirt that we have piled up where we're about 4 feet higher than natural grade, we can now cut this down, use this dirt to fill in up over here, and we'll create another retaining wall along the side. Just continue that process until we get to the point where we are meeting natural grade without having to retain anything. But we're gonna kind of have to wing it as we go around this side. Because the lot was a little different when it came to the grade that we started with from what the surveyor originally laid out, we have a few areas that we're just gonna have to tweak a little bit on site, and that is definitely gonna be one of them. This side over here also houses one of our retention ponds. So in Utah, we have to retain all of the water that comes on our site, whether that's from rain, sprinklers, downspout gutters, planter drains, footing drains. All of that water has to stay on our property. It's got to percolate back down into the natural aquifer. So we have to have some type of a retention basin. So our plan is we're going to put that rock retention basin over here. We can then put all of our footing drains to it, all of our downspout drains, any of our drains from our planters, and we can also kind of grade the lot itself so that everything is sloping to that. We're maintaining the water in one spot. We're getting rid of it in one spot. We will have sumps, like sump locations around the entire house. So in the event that they do get a lot of water one year, they'll be able to drop a pump down in, they can hook a hose up to it, and they can drain that water onto the rest of their 2 acres of property that they own down the hill. But at this point during construction, we're only allowed to disturb the amount that we're building on. So the rest of these 2 acres that go all the way down the mountainside over to the lake, we can't use it. However, when the homeowners get moved in, they can utilize some of that, kind of tie it back into their landscape. And if they need to get water out and away, run it down the rest of their property as long as they're retaining it on their property. Last thing I want to do today, I want to walk you back up front and show you the porta potty structure again. We talked about this on the first episode. This has been something that people are really, really excited to see. This is a building that we're required to put up by the HOA around the porta potty so that the neighbors can't see the toilets in the neighborhood on the construction sites, but also so the HOA can approve the exterior finishes for the home when it's going to get built. We actually have some of our finishes installed right now and are really happy that we're building this ahead of time because we don't like some of the finishes that we originally chose. So let's go up and check that out. I want to show you what it's looking like, how it's coming together, and show you one of the things that we're going to change at this point to make the house look a little bit different. So this is our porta potty house. This is what the HOA requires us to build in order to approve our exterior finishes, but it also houses our bathroom inside. So you'll notice it's got windows, stone. In this case, we have our Tesla solar shingle roof on top. Yesterday, we actually installed all of our stone and stone sills. The sill, the designer spec'd, does not look quite right with the stone. It's a little too gray, doesn't match perfectly well. So we're actually gonna swap this stone sill and the header over the stone wall on the window to one that just matches the stone a little closer. Now, in this community, they require that we use full bed stone. So this is somewhere between 3 and 5 inches thick, depending on the stone itself. We've decided to dry stack it, so we're not leaving really huge mortar joints. We're stacking these stones really nice and tight together, as tight as we can get with them being natural cut stones. And in this case, the example we have here, the sill is actually a Texas limestone. It is a little too gray, a little too blue for us. Doesn't quite match the stone perfectly. So we're gonna get these swapped out and the header. And then from there, we've got this Delta Millworks barnwood that we will be using on our soffit and the entire house. You got some wind kicking up, so we'll take it down. So this is a product from Delta Millworks. It's pre-finished, comes to us in very, very easy to install, honestly, packaging. This is just a T&G, goes together really simply. The color selections that we had when we were picking these, there is a lot of colors to choose from. So it was easy for us to decide on a color that we wanted to use. This will be all of our soffit underneath the house, and that is it. All of our fascia on the outside of the house will be the same as our siding materials. So we have vertical T&G siding that is the Delta Black Accoya. And then we'll be using a true 1-inch material to trim out around all of our windows to do our header. And this is the exact same color as the siding. So this is also the Delta Black. Some of the details that we have to make sure we're including as we wrap this up is how do we address these corners when we're going from a siding wall to a siding wall. We're going to be mitering our material, so we'll get that detail installed, get really this entire structure wrapped up so the HOA can come by and approve it, and then we'll keep moving through this project. This is going to be such a fun one, and there are so many crazy things happening over here. So you guys stay tuned for more episodes here on Altitude Adjustment. You know you can follow me on social media at Stephanie Builds It, and go check out RWC. Huge shout out to them for the products that we're using here today on our radiant heat. We'll be using some of their products on our exterior snow melt as well. So go check them out. They've got a lot of great products to offer. We'll see you guys next time on The Build Show.